Before we go on to learning more about normalization rules, let's first talk about reasons for database normalization. This will help you understand why we're learning normalization in the first place. So there are several reasons that we should normalize our database. Firstly, it's going to help us minimize duplicate and redundant data in the system. Also, it's going to help avoid some of these data modification issues where, for instance, I have to maintain data in several places in the database, and also simplify queries so that my queries will become easier to write, maintain, and read. So let's go into these three reasons and see what they look like in detail. So first of all, here's an unnormalized table again. So it's pretty much like our spreadsheet example. It's a big table called sales staff, and again, this is a table that serves many purposes, so it's kind of a big red flag that it's not normalized. So we're going to use this as a reason as to why we'd want to normalize the table. So the first reason is data duplication. So when you look at this table, there's a couple of things that you can see that stand out from a duplication perspective. And the big one that I see is that the sales office is repeated. So every time I add a new salesperson to a sales office, I need to repeat the sales office name and sales office number. So as this database grows larger and larger and larger, and you can think of a very large organization like a Fortune 500, Ford Motor, Citibank, large organization, there's going to be lots of redundant information in the database just because we keep repeating information. So it's going to increase storage, decrease performance, and it's become more difficult to maintain data changes. And you may think the performance is like, oh, whatever, it's just a couple characters in a column. But when you get into like data warehousing and some of these other places, a couple characters mean a lot. If you're talking about, let's take 1 billion rows, just consider this. One character is a gigabyte in 1 billion rows. So it's a lot. So we want to make sure that we're designing our tables efficiently so that our tables are reduced in size and we don't have to transport as much data across the wire to the front ends, right? That makes it more efficient and snappier to our users. Also, there's data anomalies. Okay, anomalies, what are we talking about here? These are those modification issues I was talking about. So let's go through some of these data anomalies that can creep into our data. So the first would be an insert anomaly. So let's say I want to add a new sales office. Our management comes to us and says, we want to set up an office in Atlanta, and here's the phone number. It's 555-1212. All right, so we set up the sales office in Atlanta, but no one works there yet. Guess what? We can't add it to the table. You know why? Because there's no salesperson, and we needed an employee ID because it's the primary key of the table. So we're stuck. And so until somebody hires somebody, we can't even store in our system that we have a new office called Atlanta. So we can't even start sending PO, boxes for furniture or whatever to the Atlanta office because we don't have a record of it yet. So this would be the insert anomaly. So if we had sales office in a separate table, this wouldn't be an issue. The other is an update anomaly. This one's a little more subtle in the sense that, let's say that in Chicago we need to change the phone number from 555-1212 to 867-5309 to Jenny's number, for instance. And to do that, now we need to go through every instance that we see the sales office Chicago and find it and then update it. So instead of it just being a simple update in one place in one table, the sales office table, and this unnormalized world, we're actually scanning through the entire table through an update statement and updating, one or more rows. And the other thing is that if we forget to do an update, we get an inconsistency. So if you're not familiar with the structure of the system and how data has been put in the system, You may just go, oh, I need to update the office number for Mary Smith in Chicago, and you update it, and then you forget the fact that Martin Happ also has the same office number, and that his main office number also needs to be updated, and now you have a inconsistency between the office numbers. And then lastly would be a deletion anomaly. So here we have John Hunt. So let's say John Hunt leaves the company. He retires. If he was the only person working in the New York office and he retires, now when I remove John Hunt from the database, I'm also removing the New York office from the database. Is that something we really want to do? Is there somebody else that's coming in to the New York office to replace him? Are we going to keep the New York office for storage? Who knows? The point is that just because John Hunt's retiring doesn't mean we should be completely removing the New York office. That should be maybe another decision. So again, if the New York office was separated out into its own entity, then we wouldn't have this anomaly where the one action of removing the one person from the table is coupled with the other. Okay, so that's a deletion anomaly. And then lastly, there's query issues, right? So if you looked at our table here, we have a couple query issues to look at, and the one I want to point out is that if I wanted to figure out, which salespeople serve Ford Motor Company, and I come over to the customer, to do that, I need to query all customer columns now. So it's not just as simple as saying where customer equals Ford. I need to literally say where customer 1 equals Ford, or customer 2 equals Ford, or customer 3 equals Ford. And what happens if we have a superstar salesperson who gets a 4th customer? Now we have to add a 4th field called customer 4. So the table now needs to be extended, and all our queries need to be rewritten for that. So again, this is an issue that lends itself to normalization, and normalization can fix. So these are all good reasons as to why we want to use normalization to help make our database design cleaner, help us with data issues, as well as allow us to make it so it's easier for us and our users, being developers or analysts, be able to query the database.